Welcome to The Explainer. Today, we're going to take a look at a classic security framework, ISO 2735, and really dig into how we adapt it for the completely new and kind of complex challenges that artificial intelligence throws at us.
So here's the plan. We'll walk through the 5 phases of that ISO process, but at every single step, we're going to highlight the critical AI-specific things you absolutely need to be thinking about.
All right, let's jump right into it. Your traditional incident response plan, look, it's probably solid, right? But it almost certainly has this massive blind spot because, well, it just wasn't built for the unique and, frankly, weird threats that come along with AI.
So this is really the fundamental question we have to ask ourselves. How exactly is the nature of security incidents changing? Because it is, and it's changing fast.
And this slide, this just illustrates the shift perfectly. We're moving away from the world of predictable, code-based flaws, stuff like server outages. Now, we're dealing with these complex, data-driven vulnerabilities. Things like data poisoning, biased predictions, or an AI accidentally spilling confidential training data. It's a whole new ballgame.
So that brings us to our very first phase, preparation. In the world of AI, you just can't afford to be reactive. You have to anticipate. And building an AI-ready team means getting the right people with the right expertise in the room long before an incident ever happens.
Your traditional IT and security folks, still absolutely essential. You need them, but they can't do it alone anymore. Now you need data scientists who can actually figure out why a model is behaving strangely. You need privacy experts and maybe even AI ethicists who can tackle the really tricky questions.
And it's not just about people. You also have to document a really clear communication and escalation plan, specifically for these new kinds of incidents. Think about it. When a model starts spitting out sensitive information, you need to know exactly who to call, right then and there. No hesitation.
Okay, let's move on and see how this all builds. Identifying and assessing an incident when AI is involved, well, that requires entirely new ways of monitoring and, honestly, a different mindset.
Now, this is where it gets really interesting, because our detection methods have to evolve. So for a prompt injection attack, you're not looking for malware. You're hunting for weird, code-like text in user inputs. For data poisoning, it's about spotting these super subtle malicious changes in your data supply chain. And for adversarial inference, you're basically a detective, analyzing API call logs for patterns that suggest someone is systematically testing your model for weaknesses.
So once an incident is flagged, the assessment goals might look familiar, but the challenge is totally different. Figuring out the scope is so much harder when the vulnerability isn't just a line of code, but it's buried somewhere in the model's logic. You have to move fast to figure out the impact on data, on people, on trust, all while the AI could still be live.
Okay, this brings us to the response phase. And to make this really tangible, let's walk through a concrete example of an attack that is pretty much unique to modern AI systems.
So imagine this scenario. Your customer service chatbot, the one powered by that fancy new LLM, is being manipulated. Attackers are feeding it these clever prompts, and it's tricking the model into leaking confidential information right out of its training data. Not good. First things first, containment. You can immediately throttle API access. That slows the bleeding. But the really crucial part is deploying strict input and output validations and using prompt templates. Think of these as guardrails that sanitize the bad inputs before they can even get to the model. Now, your first instinct might be to just retrain the entire model on clean data, right? But in the world of AI, that is exactly the wrong move. A full retrain is incredibly slow, it's incredibly expensive, it is just not a viable first-line response. So instead, you can use those same input validation and prompt template techniques from the containment phase, but as a surgical fix. This is fast, it's low cost, and it addresses the vulnerability without the huge cost and system downtime of a full retrain. It's really a game changer for AI incident response.
And finally, recovery. This is all about making sure the threat is well and truly gone, and then hardening the system. This means putting new guardrails in place, like stronger access controls, before you even think about bringing that AI solution fully back online.
And that brings us to the final and maybe most important phase. It's all about learning from what happened so you can build long-term resilience.
You know, the goal of a postmortem isn't about pointing fingers. It's about shifting from being reactive to being proactive. You have to analyze what went wrong to improve everything, from your data pre-processing and your security controls all the way to how you test for these kinds of attacks.
And this process can't be a one-off thing.
As you can see in frameworks like the NIST AI Risk Management Framework, it has to be a continuous cycle. The lessons you learn from any incident have to feed directly back into making your governance and risk management program for AI that much stronger.
So your playbook is updated, you've got the plan on paper, but having a plan is really just the beginning. The real, ongoing challenge is making sure your team, your processes, and your technology are truly ready for the unique test that an AI incident is going to present.